So this is National 4 and National 5 Chemistry. We are looking at Unit 1 and we're looking at formulae and calculations. And this lesson is going to focus on concentration and moles. So our aim is to learn that the concentration of the solution is measured in moles per litre. And we're going to learn how to carry out calculations to determine the concentration of a solution. So solutions. Many chemical reactions do not use solids. They use solutions. In fact, most chemical reactions will use solutions. And a solution is a chemical dissolved in a solvent, and often that could be water. Now, what do we mean by concentration? Well, solutions need to be accurately made up by dissolving an exact mass of a solid in an exact volume of a liquid so that their concentration is known. So you use a mass balance to record the mass of solid that you use, and you use an accurate piece of equipment to measure out an exact volume. And using that information, you can work out the concentration. So, concentration is a measure of the mass of solute dissolved in a volume of solvent. Concentration equals mass of solute divided by volume of solution. But remember that we can express mass in terms of moles. And so concentration is more commonly calculated as the number of moles divided by the volume of solution. The units of concentration are moles per litre. The units of moles are moles, and the units of volume is in litres. Now, this gives us the equation C equals N divided by V, where C is concentration in moles per litre, N is the number of moles, and V is the volume of solution in litres. Remember, that's important. It needs to be in litres. So we have an example of a calculation. Calculate the concentration of a solution of sodium hydroxide if we have 0.75 moles of sodium hydroxide dissolved in 500 centimeters cubed of water. Now we're going to use our calculation C equals N over V, but the volume must be in litres. Now we've been told 500 centimeters cubed. To convert from centimeters cubed into litres, we divide by 1,000. So it's going to be 500 divided by 1,000, which gives us 0.5 litres. So that's going to be 0.75 divided by 0.5 now. 0.75 is the number of moles, 0.5 is our volume in litres, and that gives us 1.5 moles per litre as our concentration. So C equals N divided by V, but the important step that we cannot forget is that the volume must be in litres. So we've got a couple of examples here. Calculate the concentration of each of the following solutions of hydrochloric acid. So example 1 mole of hydrogen chloride dissolved to make 100 centimeters cubed of solution, and secondly 2.5 moles of hydrogen chloride dissolved to make 1 litre of solution. And so have a go at doing those questions. You might need to pause the video in order to give yourself time to do those. Hopefully you've had a go at those questions and you've returned to the video. You should find that for the first one, you end up with a concentration of 10 moles per litre. And that is because C equals N divided by V. N is the number of moles, which is 1. V is the volume in litres. So the volume in centimeters cubed is 100. When we divide that by 1,000, we get 0.1 litres. And 1 divided by 0.1 gives us 10 moles per litre. For the second one, N equals C, C equals N divided by V. And this is going to be 2.5 is our number of moles. Our number of litres is 1, so it's 2.5 divided by 1, which gives us 2.5 moles per litre. We've got another few examples for you to have a go at. Again, pause the video and have a go. If you've unpaused the video, having tried these questions, the answers are 0.2, and that is 0.1 divided by 0.5 litres, which gives us 0.2 moles per litre. For the next one, 0.4 moles divided by 0.25 litres gives us 0.8 moles per litre. And for the final one, it's 0.4 moles divided by 0.2 litres, which gives us 2 moles per litre. Now, we can rearrange that relationship in order for us to work out concentration, volume, or moles. So previously, we'd only been looking at calculating concentration. We can rearrange the equation to help us work out volume or number of moles. So to calculate the number of moles, N equals CV, concentration times volume. And that equation is written on page 3 of your data booklet. So that equation is written at the front. Number of moles is concentration times volume. Remember, volume must be in litres. And we can also calculate volume, because volume is equal to the number of moles divided by the concentration. Remember, this is going to give you a volume in litres. So here's an example. Calculate the number of moles of nitric acid that should be dissolved in 250 centimetres cubed to make a 0.5 mole per litre solution. Well, N equals C times V. The concentration is 0.5 moles per litre. The volume is 0.25 litres. Now we got that 0.25 litres by dividing 250 by 1,000. And that gives us 0.125 moles. Here are a few examples using that equation. So remember, N equals C times V. Take some time to do those and then restart the video after you've had a go. You don't need the data booklet to do these ones. So if you have had a go at those questions, we'll go over the answers. Well, the first one, it is N equals CV, so that's going to be C is 1 and V is 0.2 litres. 1 times 0.2 gives us 0.2 moles. For the next one, N equals CV. In this case, C is 2 and V is 0.1 litres. So 2 multiplied by 0.1 also gives us 0.2 moles. For part C, we have N equals CV, C equals 0.2, V equals 2, so that gives us 0.4 moles. And for D, N equals C times V. C is 2 and V is 0.05 litres. When we multiply that, that gives us 0.1 moles. Now we're going to use the third equation, which is calculating volume. We calculate the volume of a solution if 0.5 moles of sodium sulfate was used to prepare 4 moles per litre of solution. So V equals N divided by C. Our number of moles is 0.5. Our concentration is 4 moles per litre. 0.5 divided by 4 gives us 0.125 litres. If we wanted to turn that into centimetres cubed, we would multiply it by 1,000, and that would be 125 centimetres cubed. So now we have 4 examples for you to try. In each case, you're going to calculate volume using the equation volume equals number of moles divided by concentration. Again, pause the video and once you've worked out all of them, restart the video. So for the first one, what we end up with, so V equals N divided by C. This is 0.4 divided by 2, which is 0.2 litres, or if you wanted to, you could have said 200 centimetres cubed. For the second one, V equals N divided by C, which is 0.5 divided by 2, which is 0.25 litres, or 250 centimetres cubed. For the fourth one, for the third one, V equals N divided by C, which is 0.4 divided by 4, which is 0.1 litres or 100 centimetres cubed. And finally, the last one, V equals N divided by C, which is 0.15 divided by 0.5, which gives us 0.3 litres or 300 centimetres cubed. And so that is the conclusion. We've seen that solutions have a concentration and that concentration has units of moles per litre. We've then looked at 3 different variations of an equation in order to calculate either the concentration, where concentration equals number of moles divided by volume. We looked at working out the number of moles using the equation number of moles equals concentration times volume. And then we also looked at how we could calculate volume using the equation volume equals number of moles divided by concentration. We also need to remember that often in questions like this, the volume is given in centimetres cubed. And in order to turn that volume into litres and use it in these equations, we divide the centimetres cubed number by 1,000 to turn it into litres. So that has been concentration and moles, and we will be looking at more examples using concentration in our next lesson.